Hey guys, Mr. Milton here. Today we're going to talk about multiplication properties of exponents. This is our first video. We'll add some more rules to this afterwards in our next videos. Okay, at the end of this video you should be able to accurately use multiplication properties of exponents to simplify exponential expressions. Alright, so let's start with an example and then move and see how that works for us. We have 3 to the 4th power times 3 to the 5th power. Rewritten, we can have 3 to the 4th power, that's 3 times 3 times 3 times 3, 4 times. And then 3 to the 5th power, which is 3 times 3 times 3 times 3 times 3. Okay, so basically this is 3 to the 9th power. This is 9 3's multiplied together, so another way of writing this is 3 to the 9th power. Okay, our shortcut for this example to illustrate is that if we have the same base, 3 to the 4th power times 3 to the 5th power, we can rewrite this as 3 to the 4 plus 5, 3 to the 9, 3 to the 9th power. Okay, what is that? 3 times 3 times 3 times 3 times 3 times 3 times 3. How many is that? That's 6, 7, 7, 8, 9. I hope I did that right. Okay. Okay. Alright, so again, the bases must be the same to use this property. They cannot be different. Oh, wait a second. I have a button on this calculator. 3 to the 9th power. There we go. Now, I won't necessarily ask you guys to write numbers out like this. The ones that I will expect you to simplify are the ones that are, let's say, I guess small enough for you to be expected to do it. I guess if you're using your calculator to simplify those exponents, then you can skip that. Alright, also remember, or make sure that the operation between the two expressions is multiplication. Okay, so although we add the exponents as kind of a shortcut seeing what's happening, the operation that was happening between 3 to the 4th power and 3 to the 5th power was multiplication. So it can't be 3 to the 4th power plus 3 to the 5th power. It won't have the same effect. Okay. Okay. So let's look at a few of these problems. It says simplify each exponential expression. Here we have h to the 5th power times h to the 2nd power. Again, we can rewrite this as h to the 5 plus 2. Same basis, so h to the 7. We have 2 to the 7th times 2 to the negative 3rd. We could move this to the denominator if we wanted to. That would kind of add steps in this case. But so we have 2 to the 7th plus negative 3. So plus a negative is just minus 7. Minus 3 is 4. So we have 2 to the 4th power. You can leave that there. You can change it to 16. For number 3, we have b to the 4th power times c to the 7th power. Notice here our bases are not the same, so we won't be able to just mush them together. We have b to the 4th, c to the 7th. That's how we'll leave it. Okay, and that's okay. Number 4. Here all of our bases are m's. So it works with 2. It will also work with however many we have as long as they have the same base. So negative 9 plus 5, which is negative 4, minus 2. That gives us m to the negative 6. Now, remember that our final answer, we will not have negative exponents. And so we still need to keep in mind all the rules we talked about in our last lesson. 1 over m to the 6th. Okay, since it's a negative exponent, we'll move it to the denominator to make it happy. Okay, number 5, we have 6 to the 8th times 6 to the negative 8th. So we have 6 to the 8 minus 8, which gives us 6 to the 0 power. Anything to the 0 power is 1. Number 6, we have p to the 8th plus p to the 3rd power. Notice that this is a plus. Okay, we can't add these two together because they're not like terms. They don't have the same like exponent either. So we'll just have to keep this as p to the 8th plus p to the 3rd. Just kind of keeping your eyes open, making sure that you see that. If at any point, guys, you want to stop, try these problems, and then kind of skip forward to see if you got it, and then rewind if you need to see where you went wrong. Then go ahead and do that. We'll go into some more confusing problems here because we're adding a little bit more of a mix between numbers and variables, which tends to make the wheels turn a little bit more. Okay, so here we have 2 into the 5th times 3 into the negative 2nd. Again, this is just all multiplication. 2 times into the 5th times 3 times into the negative 2nd. And so with multiplication, again, we can order it however it makes it easiest for us to do the problems. So if it's helpful for you, you can even write this out and say, okay, I'm putting my numbers together. I'm putting my ends together, and if there were any other variables, you put those together. This is just an organizing tactic. So 2 times 3 is 6, into the 5th, into the negative 2nd, so that gives me 5 minus 2. So I have 6 into the 3rd. Okay. Notice I can multiply 2 times 3. For some reason during this lesson they're like, well, this is one's a 2 and one's a 3, so I can't multiply them. We've been multiplying 2 times 3 since the 2nd grade. Okay, so we can still multiply those. Okay. Alright. Another problem, kind of the same thing. We have 6 times 3, y to the 3rd times y to the 4th times y. Now this is a really tricky problem because a lot of people will write this as 18 times y to the 7th. But it is not y to the 7th, because know that even though there's nothing written here, it's 1. Y to the 1st power. Because if it was y to the 0 power, the whole number would just be 1 and we wouldn't need to write it at all. It would be y to the 3rd times y to the 4th times 1, which doesn't do anything. But it's times y, because it's y to the 1. So now we have 3 plus 4 plus 1. Which is y to the 8th. So if you need to make a habit of writing a 1 here, do that. If that makes sense to you that, oh yeah, it has to be 1, then you don't necessarily have to write it. But either way, this is to the 1st power. Make sure you include that. Number 9, we have c to the 4th, c to the negative 8th, and then we have d to the 3rd. Okay, so as I multiply these two together, 4 minus 8, that's to the negative 4. And then d to the 3rd is fine. So I have d to the 3rd. I need to move this to the denominator over c to the 4th. Okay, so if you didn't get what I was saying by having to think a little bit more with the mixed numbers and variables, hopefully you see that now after these first 3 problems. Okay. We have 2 times 7 times 3. Organizing this for myself, m to the 3rd times m to the 4th, and p to the 5th. Okay, so that should give me 6 times 7, which is 42. M to the 7th, p to the 5th. Alright. Make sure you pay attention to the operations that you're using. It's so easy, so easy for you to say, okay, I'm multiplying and do 3 times 4 instead of 3 plus 4 with these exponents. So make sure that you're thinking about this a little bit more than just looking at numbers and writing them down. Okay, and that's why I'm organizing myself here. It's a good habit to get in, especially if you're just starting this. Alright, so again, I'm going to write this 1 here to remind myself that there's a 1 there. So 10 times 3 is 30, x to the 9th, y to the 4th. Okay, notice there's no difference in how we handle this problem, whether they're separated with parentheses or by the multiplication sign. Number 12. Okay, I look at this, I have k to the 1, so as I simplify this, I have k to the negative 2 up top. I'm going to have n to the negative third on the bottom. Both negative exponents, they need to move. So now I have n to the positive third up top, because the base is connected with its exponent, k squared on the bottom. Again, base is connected to its exponent. And there we have it. Some problems there dealing with multiplying exponents, but also remember that all the rules that we learn, we're really building on top of it. So even though we go to the next section, it's not one of those things where you can say, oh, I did zeros, I really didn't understand it, I'm glad I'm moving to the next thing. Understanding zero and negative exponents is going to be critical for everything we do from here. Alright, so speaking of that, let's look at scientific notation and how that plays part in our rules. So, last time we did multiplying with scientific notation, we showed that we can reorganize the problem to help ourselves out. We'll do the same thing here. We have 2.5 times 10 to the 8th times 6 times 10 to the 3rd. And so we're going to reorganize the problem so that we can do that. Okay, so we're going to multiply the a values, reorganize it so you're doing 2.5 times 6, and we're going to add the exponents. Again, we can add the exponents because they have the same base. 10 is our base, 8 and 3. And then we're going to make sure our answer's in scientific notation in the end. So as we've been doing for the other problems, I have 2.5 times 6, organize that here. 10 to the 8th times 10 to the 3rd here. And so I have, that's going to give me 15 times 10 to the 11th power. Okay, now that's accurate, but I want to make sure I write my answer in scientific notation, and so I'm going to do that by moving my decimal where it needs to go. Okay, and so I have 1.5. Here this said move right 11 times, and then I moved left. So what's it going to tell me now? Well, you had to move right 11 times, but now you moved left, so in order to go where I want you to go, you have to move right one more time. Move right 12 times. Alright. You can pause it and try this on your own in this next problem, and then unpause it to see how it goes. So in this next problem, we had 9 and 7, and then we have 10 and negative 6, and 10 to 2. And so 9 times 7 is 63. That gives us 10 to the negative 4. I had to move this to the left 1, so we have 6.3 times 10 to the negative 3rd. Alright, try this challenge problem out, bring it in, see if you're able to substitute and evaluate. Alright, see ya.